Okay, so good afternoon, ladies and gentlemen. Let me introduce Mark Liberman from the University of Pennsylvania. He's a professor of computer science department as well as a professor of linguistics. As you probably all know, he's the director of the LDC. I'm sure that all of you, one way or the other, have benefited from what LDC provides us. And personally, I must say that one of the most successful projects we have done in Prague was actually a tree bank which was modeled by the Ben tree bank released by LDC, even though the contents are slightly different. Also, I should say that Mark finished Harvard at 69, and then got a master's in linguistics from MIT in 72, and his PhD shortly afterwards. And he will talk about linguistics, and we will learn something about the Yoruba language, right?
Perhaps. There's a handout. This is an experiment in cross-cultural communication. And linguists, as you may have noticed, if you have encountered, those of you who are linguists or those of you who have encountered linguists, know that linguists very often like to have handouts. And this is a case, I think, of a species adapting to the requirements of its environment because the kinds of information that linguists talk to each other about very often are sufficiently intricate that being able to look at small print on several sheets and look back and forth as you're trying to understand what someone is saying about it remains the most efficient means of communication, even if overheads or other sorts of graphical aids are also used. This is an experiment in intercultural or cross-cultural communication in another respect. I was trained as a linguist and then spent 15 years at Bell Laboratories working with engineers and a few other linguists, but at the time that I went there, I was really the only linguist around much of the time. And I very quickly learned that these different groups have very, very different ideas about what's important and also about what's interesting. And they have these different ideas, I think, for good and sufficient reasons in the end. One is not right or wrong, and the other is not necessarily right or wrong, but they are different. And today I'm going to talk to you about some of the things that linguists find interesting and think are important. But I'm going to make some side comments along the way about why many engineers, why engineers as engineers would not think that these things are important and therefore might not be interested in them. And we'll try to draw some more general conclusions at the end, perhaps in the course of discussion, about what this means for cooperation between the nations involved here. So Yoruba is language spoken by about 35 million people in southwestern Nigeria and some adjacent parts of Benin and other adjacent countries. And like most of the languages of sub-Saharan Africa, it's a tone language. Individual syllables in Yoruba can have high, mid, or low tone as a matter of their lexical identity. And with a couple of minor exceptions, the distribution of these tones is in principle free, so that a monosyllable can have up to 3 different tones, and a dissyllable can have up to 9 different tonal patterns, and a trisyllable can have up to 27 different tonal patterns, and so on. Here are some examples for monosyllables and dissyllables. So ra with high tone means to disappear, ra with mid-tone means to rub, and ra with low tone means to buy. Monosyllables The monosyllables here are all verbs because there are no monosyllabic nouns in Yoruba. And there are examples given there of disyllables, all nouns, exemplifying the 9 possible combinations of high, mid, and low on 2 syllables. The bottom row exemplifies one of the facts of uniform distribution of these tonal patterns in Yoruba, which is that most Yoruba nouns begin with a vowel, and that vowel can be mid or low, but not high. So all disyllabic nouns beginning with high tone all begin with a consonant, as those do. Now suppose that a linguist and an engineer were together undertaking the task of working on this language. That's, of course, in itself intrinsically not all that plausible, because Yoruba, although it's spoken by a reasonable number of people, is not a terribly economically important language at present. Certainly, Microsoft and IBM are not working hard to put out Yoruba versions. I'm sure that they have it on their list, but it's perhaps down the list a ways.
All that will require nuclear weapons.
Yes. But there's a good deal of interest these days on the part of the US government in being able to provide speech and language technology in low-density languages, and Yoruba is actually fairly high density as low-density languages go. It's spoken by a lot of people. It was first reduced to writing and a standard language created about 150 years ago. A substantial fraction of the population that speaks it is literate in Yoruba. There's a good deal of publication in the language and so on. Now, as we go on to learn a few more things about the language, one of the first things one would notice is that when verbs, which always end in a vowel, combine with nouns, which almost always begin with a vowel, the 2 vowels coalesce into a single vowel, which is almost always one or the other of them, although it's not possible to predict in general which one it will be. I should say just a couple of words about the writing system. It's fairly straightforward, except for the E and O with dots under them, which are the non-advanced tongue root variants of the vowel, e and aw, respectively. And syllable final nasals, as in SIN here, represent nasalization of the vowel rather than a nasal consonant, so that's pronounced si. So as the first panel here indicates, when we combine wa with eko, we get weko, where the second vowel has 1. But when we combine mu with iwe, we get muwe, where the first vowel has 1. And although there are some phonological subregularities, for example, that the vowel orthographic I always loses, in general, you can't predict which of the 2 vowels will surface, and certainly both the linguist and the engineer, it appears you can't predict. You have to know what the word is, what the words are. And sometimes, actually, there are 2 versions that mean slightly different things. So this would be one of the points that the linguist and the engineer would be interested in approaching, because when you see Yoruba text, if you want to figure out in a verb-object combination what the verb is, and what the object is for that matter, you've got to solve this problem, and it's often, in principle, ambiguous, based on the contents of the lexicon, although it may not be ambiguous based on what the principles are for that particular combination of words. But what I actually want to draw your attention to here is something that the linguist would tend to focus on, as well as this interesting question about what happens to the vowels, which I'm not going to say anything more about, and that is what happens to the tones. And I'm not actually going to go over all of the cases in detail. but just in this summary form. And I'm going to begin actually by giving you a summary of the summary, which is that the tones combine in a way that makes you believe that mid-tone doesn't really exist. This is actually what the orthography implies, because high tone is symbolized with an acute accent, and low tone is symbolized with a grave accent over the vowel, and mid-tone is symbolized with no marking. So when we combine a high tone verb with a noun that begins with a low tone, what we get is a dissyllable whose first syllable is high and whose second syllable is rising. So the contour is maintained. On the other hand, when we combine a high tone with a disyllabic noun of the form mid-high, that begins with a mid-tone, what we get out is simply a dissyllable, both of whose syllables are high. So the contour that was originally present, you know, high, mid, high, has disappeared and has been replaced by a simple sequence of high tones. And this property of the tonal system is called stability of the high and low tones. That is, they're generally retained as vowels coalesce, whereas the mid-tone simply goes away. It acts as though it's not there. It acts as though it doesn't need to somehow be retained in the output. Now, having noticed this, the linguist will begin to wonder a little bit about what this means for the representation of tone and for other tonal phenomena in the language. The engineer may also wonder that, but will be quite happy simply to observe that this is a finite set and quite a small one of rules. And as long as we can write down what happens in each of a small number of distinct cases, we've covered the ground that has to be covered. And really nothing more for the moment needs to be done. As we begin looking through the rest of the system of Yoruba, focusing with our attention focused on tone, we notice a certain range of cases in which tones change when we put things together. So if we look at the object pronouns, o with a high tone is the subject pronoun. We take a high tone verb, ko, to teach, and combine it with all of the possible object pronouns, mi, e, o, wa, yin, and wa, meaning, you know, he taught me, he taught you, he taught him, he taught us, he taught you, plural, he taught them. All of the object pronouns in that case show up with mid-tone, except for the second person plural, which has high tone and an extra copy of the vowel of the verb. Whereas with a mid-tone verb, the second person plural has no extra copy of the vowel of the verb, and it, along with all the rest of the object pronouns, have high tone. And likewise, after a low tone verb, all of the object pronouns have high tone. So again, the response of the engineer is to be happy that the facts are no more complex than this. This is, after all, only 18 categories of outcome. They're exceptionlessly triggered by knowledge of the tone class of the verb, and so we're done with this and we can go on to the next problem. The linguist is likely to wonder why. Why does this, what is going on here? Why is it the high tone verbs after which the object clitics have a different tonal category, and what is going on with this case? Here's another class of cases in which tones change in context. There's an emphatic particle, which is low in tone and is basically just a copy of the vowel of the word that it follows. It's like an exclamation point, so to speak, exclamation point morpheme. It's low in tone ordinarily, except that after a low tone word of whatever form class, it's mid in tone. So this extension of the vowel is low tone after mid tone, it's low tone after high tone, but it's mid tone after low tone. So I see that there are a few linguists in the audience, so would somebody at this point like to raise their hand and tell me which three-letter acronym this reminds them of? Right, okay, so there's a general observation that linguists have made originally made by Will Laban in 1973, about tonal patterns in Mende, but applied not only to tone but to other kinds of segmental sequences, that observes that often what is sometimes called dissimilation occurs. That is, sometimes when things that are the same, two high tones, two low tones, two aspirated consonants, whatever, come to be together, one of them changes, or in some other way something happens, indicating that having two adjacent items with the same specification is a fault to be corrected, so to speak. And this generalization goes under the name of the obligatory contour principle, which is not the happiest name, but it's the one that came up originally in Laban's work. And he called it that because when you put morphemes together in Mende, ordinarily their tones accumulate in a string, except that whenever you get two adjacent tones that are the same, one of them disappears. And so he argued that this was because the only thing that really mattered was the contour rather than the number of items of a particular kind. And so he called it the obligatory contour principle. Now, for a linguist interested in phonology, this much of the system is thus quite interesting because it suggests that there's some kind of OCP, obligatory contour principle, kind of activity going on in Yoruba. And so the natural thing to do is to begin looking around in the language and see where else it happens and perhaps where it doesn't happen, and how to predict what happens to correct the apparent fault created by the adjacent like tones. The engineer is likely to be a little bit impatient with this interest on the part of the linguist, because once you've looked around to figure out what the cases are in which this happens, you've described the facts adequately to write rules to capture their activity in a model of Yoruba word formation and sentence formation. And there's no added gain in any obvious way to be achieved by asserting that these different cases are instances of the same thing, because you've got to write the rules anyway. The number of rules involved is quite small, and the fact that you might be able to reduce from 18 to 6 or something like that is just neither here nor there, especially because the work involved in writing a more general rule may very well be greater than just accumulating the simple and concrete cases, which, as I said, are not very many in number. But let's go on anyway. Here's an example of the exclamatory of a particle which can either be used for exclamations or for vocatives. That is, one can add it to a noun phrase, say one meaning, say, ishe, poverty. This is an invariant particle, o, with a low tone. Isheo, meaning what poverty. So it's a little different from the emphatic particle. And it's also used for vocatives, when you want to call to someone. The equivalent of calling George, like that, is to add this particle to the name. This particle, when added to a word with mid-tone is simply O with a low tone. When added to a word ending in a high tone is again simply O with a low tone. But when it's added to, let's say, a disyllabic noun with the form low-low, that is first syllable low, second syllable low, there are actually two possibilities. One is that we can introduce an extra copy of the O, which is mid-tone, or we can remove the low tone from the last syllable of the verb, of the noun. And in either case, of course, the low tone winds up next to a mid-tone rather than to another low tone. If we put it next to a word that ends in the sequence mid-low, for example, as in agol, stupidity, we can introduce the additional sort of buffer vowel as before, but we're not permitted to delete. We're not permitted the solution in which you can delete the final low tone. And that's obviously, one imagines, because in that case the low tone, the tone of the verb is completely lost, whereas in the other case there's another copy of it sort of adjacent. And the linguist at this point is, kind of hopping up and down a little bit because he can already see how to write the constraints and or rules to get this to work out. And the engineer is scratching her head and hopping up and down for a different reason, namely impatience to stop messing around with these solved cases and get on to some of the interestingly unsolved problems, like how in the world to figure out which vowel survives in verb-object combinations, which the linguist has given up on because there doesn't seem to be any regularity to be found. And I'll skip over this rather quickly, but the possessive pronouns in Yoruba come in two flavors. They're the sort of bound versions, which are used in things like his book, his house, his car, and then there are sort of free versions that are used in forms that are the equivalent of a car of his, or that car is his, or something like that. So they're used when they're not really adjacent to the noun that they modify. And this V here doesn't mean the segment V, rather it means a vowel which assimilates to the previous vowel, whatever it is. And there's nothing very interesting going on here because these forms are invariant. They don't change except for assimilating the vowel, which is normal in Yoruba, as this example indicates. That is, the tone pattern and so forth is unchanged. And in particular, we do see a case in which two low tones, for instance, wind up being adjacent to one another across the boundary between the noun and the following possessive pronoun, and there's no problem, it seems, nothing happens. And the linguist is now interested, again, even more, because this prohibition on two like tones is not obviously a general fact about putting words together into even tightly bound constructions in Yoruba. It seems to be a fact about putting certain elements together. And so far it appears that the elements that are subject to it are the monosyllabic ones, maybe. And this is suggestive because it reminds the linguist of a fairly widespread process known as cliticization, in which certain words that are sort of prosodically insufficient, not strong enough to stand on their own, wind up getting combined with other words with various consequences for the phonology, whereas words that are big enough to stand on their own don't have this property. And the commonest sort of minimality condition for this sort of business is having two vowels, in effect, two moras. So this, again, look, the linguist is now smelling a paper to write, and the engineer, again, is getting even more impatient because basically, who cares? Looking a little further, the linguist finds that this suspicion is justified because these singular possessive pronouns have reduced forms in which the initial vowel deletes. So they become potential clitics because they have only a single vowel. And specifically, the third person, whose second syllable is lo, now behaves exactly like some of the other cases that we've seen, namely a buffer vowel appears, or in the case of a low noun, the second syllable becomes mid instead of low. Somewhat later, in the course of poking around in other parts of Yoruba syntax and phonology, our intrepid pair come across the subject marking high tone. In Yoruba, whenever you have a subject-verb combination, when you have a full subject, not just a pronoun, but a pronoun, there's a high tone that appears between the subject and the verb. Presumably it's some kind of auxiliary element, but it's purely tonal. So if you have a mid-tone noun like omo, child, and a mid-tone verb, lo, go, you put them together to mean the child went, it becomes omolo, with a high tone that appears marking the end of the subject. And as the rest of the examples here show, it applies to the end of complex nouns here, omo okunrin, a male child. And if the subject ends in a low tone, then what you get is a low-high contour. Oko, mid-low car becomes something like oko, mid-low-high, when it's in the subject position. However, as one looks across further examples, there is a class of cases ending in mid-tone that work differently from omo and other examples in which the high tone takes over the last syllable of the subject. An example is given here. There's a name, omole, mid, high, mid. Yoruba names are phrasal. That is, they're always sentences. Yoruba names are sort of like dances with wolves or something like that. It's that kind of approach. And this name happens to mean the child is difficult. But it could be just someone's name. It's actually quite a common name in Yoruba land. And if it's omole who goes, then the subject marking high tone doesn't just invade and replace the mid-tone at the end of the subject. Instead, you get a mid to high contour, which is a little bizarre because everywhere else in Yoruba, mid acts like it's not even there, and so you never get contour tones between mid and other elements, although you frequently get low-high and high-low contours as tones get added together, vowels delete, and so on. And as the following examples are intended to illustrate, this particular realization of the subject marking high tone after a low final subject occurs just in case the subject ends with the sequence high mid. I'm sorry, after a mid final subject. Applies just in case the subject ends in the sequence high mid. In that case, the mid becomes a mid high contour. If the subject ends in a mid tone with any other previous tone, the high tone, the subject marking high tone simply replaces the mid-tone at the end of the subject. The linguist is now even more excited because this is obviously just another instance of the same phenomenon. Because if in omole the subject marking high tone were to invade and replace the mid-tone at the end, you would now have a high tone sequence created by adding a clitic element to the end of a word. And we've seen systematically across Yoruba this isn't allowed, and whenever it would otherwise happen, something intervenes to stop it. And what intervenes here is that the mid-tone of the final syllable of the subject is actually retained, and the high tone sort of floats out there in the juncture, and you just make a contour to it. Again, the engineer is not excited about this discovery. The engineer is happy to know this rather recherché fact about the tonal patterns of Yoruba subjects, and is happy to store it away for further use in whatever systems are built. But the argument that this is somehow the same fact as the distribution of tones in the object pronoun clitics, for example, and in the emphatic vocative particle, and in the reduced form of the possessive pronouns, leaves her quite cold. Then the linguist stumbles across the most wonderful example. As I said before, I believe verbs in Yoruba are generally monosyllables. Nearly all Yoruba verbs are monosyllabic. And you can make compound verbs by so-called verb serialization. You can sort of put verbs together. This is the, go, do, X kind of thing. And you can also make idioms sort of with special meanings through combinations of verbs and objects, but these are generally intransitive. So the number of polysyllabic transitive verbs in Yoruba is tiny. You can apparently count them on the fingers of one hand and perhaps have one or two fingers left over. But it does happen that there is at least one disyllabic transitive verb with the tone pattern high. And this is a verb that means to get someone in trouble. And if we look at the tone patterns of this verb followed by the object pronouns that I told you about before, the linguist is excited to see that the following occurs. As we expect, in all the cases but the second person plural, the high tone of the object clitic goes away, so as to avoid a tonal OCP violation. In the case of the subject mark, in the case of the second person plural, we have this alternative form that we've seen before, in which a copy of the final vowel of the verb is introduced in order to separate, and we don't lose the high tone. And the version in which the high tone of the object is lost is not permitted. This is no good, as this star indicates. But interestingly, in just that case, we can also produce a form in which the high tone of the final syllable of the verb goes to mid. And this is exactly the option that we had in the case, for example, of the exclamatory vocative particle and the reduced form of the object, of the possessive pronoun, just in case the host, the word the clitic attaches to, had two copies, had of the tone that was meeting across the boundary, that is ended in the sequence high, or low, depending on the tone of the following element. So this indicates another interesting generalization, that there's something in common between the solution that involves the introduction of the extra vowel and the solution that involves the loss of the tone at the end of the host. Now, the linguist, having immersed himself in the complexities of the Yoruba tonal system as it affects clitics, is really excited about this case, precisely because of its rarity. This is perhaps the only word in the language about which this question could be asked. And this must be a class of facts that Yoruba speakers have hardly ever heard, because God knows they're hardly ever likely to come up, certainly in this paradigmatic form. Nevertheless, speakers of standard Yoruba all seem to agree about these facts. Just the same things that make the linguist excited about these facts make the engineer completely impatient of these facts. This is a case that is never going to come up, and so who cares?
Where's Fred?
Well, I'm speaking as someone who has worked as an engineer as well as a linguist, and so I'm speaking for two sides of my own professional personality here. If I am interested in modeling the tonal patterns of Yoruba, this is not I can think of 100 things to worry about before worrying about this. And then I can think of lots of other problems in the language and lots of other languages to work on before worrying about this. This is not a case that matters to the performance of a system. And however, it's important to the linguist because the linguist is interested in the question of what the underlying cognitive principles really are, and the linguist in this case has convinced himself that there are some underlying cognitive principles. Of course, linguists are not stupid, and they know that people are capable of memorizing a lot. They have to memorize their whole lexicon, after all, and they're capable of memorizing lots of specific things about individual forms and form classes in their language. But in this case, the linguist has convinced himself that there's some interesting set of generalizations about what happens to like tones in host plus clitic combinations in Yoruba. He's convinced himself that this is related to or connected to similar but not identical classes of facts in lots of other languages, facts about tone as well as other things, and that he's really on the track of something important about the cognitive apparatus that lies behind language use. And he's precisely excited about this case because the fact that Yoruba speakers agree about how it works, despite its completely recherché and peripheral nature, means that they don't agree about it because they've been drilled. They don't agree about it because they've heard cases like this a lot. They agree about it because they've made a certain generalization, conceivably to cases that they've never heard before at all, certainly to cases they've never consciously thought about. So it stands for the linguist as an interesting piece of confirmation of a hypothesis. And the fact that the confirmation is in terms of a rather recherché fact is no more of a problem than it was for Harvey Fletcher when he worked for the Millikan of the Millikan oil drop experiments, projecting images of oil drops on the wall and measuring their rates of motion under different electric charges and concluding that electric charge was quantized. It's not that there was any particular practical value in predicting the rates of motion of charged oil drops in an electric field, but rather that those peculiar facts seem to be confirmation of a more general, of course, in this case, much more important scientific hypothesis, namely the quantization of the charge of the electron. That is, the linguist's joy at finding this peculiar fact is, whether correctly or not, a kind of scientific joy. He's excited about the fact not because it matters to the description of the language, not because it's useful in building a system. It might or might not be helpful in the end to get this aspect of Yoruba right in building some system for dealing with it, I don't know. But because it constitutes a kind of vindication for a certain claim about the general cognitive system that lies behind the structure of this language. Now, just to give you a little bit more information that will convince the engineer even more that this is not an important set of questions, and will convince the linguist even more that there's something here worthy of further investigation. I want to point out that these combinations of host word and clitic, that is a phrasally independent word that becomes combined into a phonological word, so to speak, because it's in some sense prosodically insufficient. That's the only part of the Yoruba system in which this kind of tonal OCP, this prohibition against adjacent like tones across the boundary, operates. So within derived nouns, there's no problem whatsoever in having, say, low tone preceding low tone between a prefix and the host. In a compounding of a kind that's involved in sort of agentive-like constructions, there's no problem in having high tone sequences across the boundary. With reduplication, there's no problem in having low tone sequences across the boundary. And in the idiophone system in Yoruba, Yoruba is one of the many languages in the world that have a very extensive system of idiophones. This is a corner of the vocabulary in which phonetic symbolism rules. And the size of the vocabulary is open-ended. That is, you can create new words. This is sort of the you know, jingle, jangle, swish kind of end of the English vocabulary. As in English, we can sort of make up new words of this kind, like, I don't know, smoosh or something like that, which I suspect is a neologism of not too ancient date. In these languages, much more frequently than in English, people can and do make up new idiophones. And there are also lexicalized idiophones. Anyway, here are some examples from Yoruba. So, janja means small, shapeless piece. And if we add the suffix la, janjala, that means a very small, shapeless piece. And tonto means small, roundish piece. And if we add lo, it becomes a very small, roundish piece. And be means a small, handy object, and so on. And again, this is some kind of derivational process, and there's certainly no prohibition against like tones there. So I included some additional material from another language that illustrates the same class of points somewhat more succinctly. We're coming towards the end of the time, but maybe I'll just see if I can do this in 5 minutes. Maucacan is a language of the Manding family spoken by a couple of 100,000 people in northwest Cote d'Ivoire. The Manding languages number 17 according to Ethnologue and have about 10 to 15 million speakers in West Africa. They're all descended from the language of the Malian Empire of the 13th century AD, whose speakers spread out sort of mostly south and west into 5 or 6 countries, what are now 5 or 6 countries in West Africa. And these languages, the time depth of separation of these languages is not terribly great, so they're all almost mutually intelligible, probably about 1,000 years of time depth. Again, like most of the languages of sub-Saharan Africa, they're tonal, but in a very different way from Yoruba. In Maucacan, by the way, Mau is the place they live, the Mauca are the people who live in Mau, and Maucacan is the language of the people who live there. A word of whatever length has 4 possible tonal melodies. They're low, rising, and 2 types of high. The first type of high has a somewhat lower pitch in context, and following clitic words remain high. And the second type of high has a somewhat higher pitch, and following clitic words become low. So to exemplify, sa with low tone means sheep, sa with rising tone means salary, sa with high tone means either squash seed or magical charm. And if we add the plural morpheme, we can differentiate between salu, squash seeds, and salu, magical charms. So there's a kind of implicit low tone in one case and an implicit high tone, so to speak, in the other case. And then just for completeness, we can see that in the low tone word, the following plural is high, salu, and in the rising tone case, it's low, salu, salaries. All these contrasts exist on single vowels. I happen to have chosen a word with a double vowel because it was the only one I could find that had 4 different tone patterns on the same morpheme, on the same segmental sequence, rather. But there's no requirement of having 2 vowels in this language. And longer words also are restricted to the same 4 basic tonal melodies. So there are a few examples given down here. Rather than being like the case in Yoruba, where the tonal choices are made on a syllable-by-syllable basis, in Mao Kakan, the tonal choices are made on a word-by-word basis. As this implies, when you make compound words, the tone of the result must be one of the 4 possible tones. And Mao has very productive, very commonly used compounding techniques, as English and German do, for example. So, for example, ye is a kind of fish, kun is head, and ye kun is fish head, and so on. So there's just a way of making words out of words. When you do this kind of compounding, there are obviously 16 possibilities, because the first word can have 4 tones, 4 tonal classes, and the second word can be of 4 tonal classes, and the result is going to be one of the 4 tonal classes. So we have a mapping from a 4x4 array to 4 possible values. And this is the way that mapping works, using the symbol sequence that I gave on the other page, but we could just have used numbers. So this is tone category 1, tone category 1, tone category 1, 1, 2, 2, 1, 3, 1, and so on. Now again, the engineer's natural reaction to this table is to say, good, what's next? Now we know how to predict the tonal patterns of compounds. Problem solved. Let's look for something unsolved to take care of.
How bad is these engineers?
Pardon?
How bad are these engineers?
Well, there's something to be said for their point of view. If you want to solve problems, you have to pay attention to the problems you want to solve, and not spend all your time wandering off into corners, trying to figure out reasons for things whose external distributions you perfectly well understand. I mean, if there's a straightforward way to capture the external distribution of a phenomenon in language, then from the point of view of modeling its external distribution in a system, it's not obvious, without any further proof at least, that there's any benefit to understanding what lies behind that distribution. Sometimes there might be, because there might be interactions with other parts of the system that would be simpler if you understood it and so forth. That's what linguists always say. But it's surprising how rarely that turns out to be true. Does anybody see what the rule, what the sort of principle is here? It's pretty simple, really. You can treat these 4 tone classes as a cross product of 2 binary choices. The first choice is whether the word begins low or not. And the second is the question of whether it has a final fall or not. In a sense, you could treat this as low tone at the beginning or not, low tone at the end or not. But for various reasons, it's actually more helpful to think of the final choice as the presence or absence of an accent, like the pitch accent in Japanese. And the rule is then very simple. The compound has an initial low if the first word of the compound has an initial low, and otherwise it doesn't. And the compound has an accent if the second word of the compound has an accent, and otherwise it doesn't. And that sort of expresses, that allows you to predict this table. And the fact that that way of putting things allows you to predict this table again makes the linguist interested. The linguist wants to know more about how these elements, apparent elements of these tonal categories function in the language, and whether there's some other evidence for this decomposition, and so forth and so on. The engineer is likely to take this kind of show me attitude that, can you show me, I mean, even assuming for the sake of argument that we're interested in modeling this language, that this decomposition is really going to help me in the rest of my modeling. The argument that there's a phenomenon here to be explained, and that we seem to have the beginnings of the explanation in hand, is not one that carries any weight, and not one that should carry any weight for someone interested just in modeling the external patterns of distribution of the data. The linguist's excitement about this case is likely to be increased if he knows something about the facts of Japanese, because it happens to be the case in Kyoto and other Kansai dialects of Japanese that there are, as the description usually goes, two tonal melodies, one of which is low, high, low, and the other one is just high, low for accented words. And that words can either be accented or not, so there are accentless words that don't have a final fall. Now, in Japanese, there's another degree of freedom. Given that a word is accented, you can pick which syllable it's accented on. It doesn't have to be accented just on the final syllable. But there is something sort of similar to this case, which is that if the word is final accented, the fall doesn't actually appear unless you add a toneless clitic, in which case the clitic is low, whereas with an accentless word, if you add one of these toneless clitics, it remains high. Furthermore, in the Kansai, in the Kyoto dialect, you can do compounding. And the rule for determining the accentual status of the compound in Kyoto is very simple. If the first word of the compound has a low beginning, then the compound has a low beginning. If it doesn't, it doesn't. The rule for determining the accentual status of the compound is also very simple. If the second word of the compound is accented, then the compound is accented. And if the second word of the compound is not accented in isolation, then the compound is accentless. So abstracting away from certain differences, such as the movable accent, in fact, this makes Maukakan look almost exactly like, from the point of view of its accentual system and its the rules for combining tone and accent in compounds, like Kyoto Japanese. Now, it happens to be true that in the 16th century, the Portuguese were in contact with both groups. The Portuguese had trading posts both in West Africa and off the coast of Japan, on the coast of Japan. But I think it's quite unlikely that this confluence of cultural factors is due to transmission through Portuguese seafarers, although I guess it's conceivable. The linguist is likely to feel again that he's on the track of some important aspect, some relevant aspect at least, let's say, of the cognitive architecture of the language faculty. And that the fact that these two systems work in such an analogous fashion in two such widely separated parts of the world tells us something about the approach of the species to language. The engineer, I don't want to paint this engineer as being too much of a Philistine, may accept that argument from the perspective of discussions of the possible cognitive architecture of language, but the engineer is not interested in the cognitive architecture of language. or shouldn't be. If the engineer is paying attention to the cognitive architecture of language, then the engineer is not doing a proper job for the person who is paying his or her salary. Because the engineer is being paid not to figure out what the cognitive architecture of language is, but to produce systems which imitate its external distribution of properties. And therefore, the engineer will ask in a very hard-headed way, is the time that you're spending looking into these interesting analogies of properties actually working towards making the system better in the practical ways that it will be judged in terms of, or is it entirely off to the side? Or worse, is it perhaps getting in the way because it makes us add complexity to our representations and internal processes, which make it harder for us to keep track of the surface distributions that we need to explain. Now, I don't want to paint too bleak a picture of this relationship. The fact is that linguists and engineers very often work together very well. And I've spent a substantial portion of my career working as an engineer as well as a linguist, and I continue to do things which I consider to be engineering. And I could have, for a different audience, expressed this talk or created a somewhat different talk in which the audience would become impatient with the linguist rather than impatient with the engineer. Especially for people who are primarily concerned to get on with the task of representing something about the way language works in breadth and descriptive detail. The tendency of linguists to focus endlessly on alternative ways of explaining small generalizations about small finite sets, which they believe they've discovered, can be absolutely maddening. And I speak as someone who has been frequently maddened by this kind of activity. The interaction between members of these two cultures works best when each one understands what the other's motivations are, and when they agree, at least temporarily, on the reasons for their collaboration and work together to solve whatever problem it is that they're jointly addressing in an efficient way. Thank you.
So it seems that, if I understand the point, that the same relationship holds between engineering and basic science, pretty much across the board. So if I think about physics, where my background is, you could say that the point of being a physicist is to look at the parts of the theory that aren't working and figure out how to make them work. If you're the engineer, you want to take the parts of the theory that are working and use them. And that's a kind of complementarity of what you want to work with and where you want to focus your efforts. But the difference is that engineers don't normally think that physicists don't have anything to say. But language engineers normally think that linguists have nothing to say. There's a difference that needs explanation. And one explanation might be that while the activities of a theoretical physicist might be focused on the parts of the theory that aren't working, there are parts of the theory that are.
Yes.
And that can be used by the engineers. And they can be grateful that, 200 years ago, some physicists figured this out. The question is, what has that status in linguistics? And what is it that we can point to language engineers and say, look, you may not be taking advantage of the obligatory contour principle in your understanding of, in your speech recognition system for Chinese. Perhaps you could. You may not be. But here's all the stuff that you're making full use of that's essential to the success of your enterprise that came out of linguistics 200 or 2,000 years ago.
Well, I think that, traditional grammatical description, I mean, we have to recognize, of course, that as a science, linguistics is not anything close to being, I mean, I was about to say as successful as physics, but one has to maybe wonder to what extent one can describe it as scientifically successful at all. I think its scientific successes are just beginning. They're somewhat preliminary now. But linguistics does have a long tradition of careful scholarly description. And the fact is that speech engineers make use of that, and language engineers make use of that tradition all the time. Whenever the speech recognition community or the text analysis engineering community undertakes a new language, the first kind of thing that they want are dictionaries. Dictionaries compiled according to the principles developed over the millennia and recent centuries by linguists. Then the other things that they want are things like texts, which are written in an orthography, which in most cases was developed in a sense by linguists, or at least on the basis, borrowed or contrived on the basis of linguistic expertise. So I think, the one problem is that linguists themselves don't adequately respect and don't adequately represent themselves as inheritors of and purveyors of the traditional, the scholarly tradition of language description, which does, it's perhaps a little bit more like traditional biology or something like that than like physics. It's partly taxonomic and descriptive and so on, but it provides a basic foundation on which language and speech engineers build. There was a time, and this comes up from time to time, that language and speech engineers felt that, with self-organizing systems and unsupervised learning and so forth, they could simply dispense with any reliance on anyone's subjective categorization of linguistic behavior, and all you really needed to do was to put a few thousand hours of audio in one end and crunch away at it long enough, and out would come the system. And you just have to, if you wanted to do transcription in old-fashioned terms, you just have to sort of figure out how to connect its categories up to words, but that would be a kind of secondary problem. And I think it's fair to say that efforts of that kind have uniformly failed rather badly, and that it's relatively rare for people even to talk that way anymore. Instead, it's just assumed that you want to start, for example, from the notion of human transcription into words, which is itself an act of linguistic description. Yeah.
Then there's the psychologist.
Yes, they're a completely different group, and they have a different perspective.
I mean, it seems to me that there are aspects of this that the psychologist has to embody in both directions. Practically, you want to know how people solve the problems, and clearly the structure that's in the language is going to be something that you have to deal with. But, I mean, I wouldn't say that, obviously we don't adopt an engineering solution to these problems either, in the sense that we sort of want to do it in a way that we're doing it as human beings, and not just find some kind of generalization that you could impose on a system that would allow you to, get there part of the time. Although it seems to me that at least the way the field is moving to some extent, at least in terms of the way psycholinguistics is developed, maybe it is pushing a little bit more to the engineering realm, at least in looking at indirect ways of accounting for the same set of generalizations that linguists pull out. You know what I'm saying here?
Sure.
Yeah.
Well, let me give an example from my own history that may help to elucidate this. One of the things that I worked on at Bell Labs was letter-to-sound rules for speech synthesis and for other applications as well. And as combined with grounds in dictionaries and so on. And one aspect of that is stress assignment. And stress assignment was something that I thought I knew something about based on my graduate work. But after giving the matter a little bit of thought, I realized that the right way to approach this as an engineer was as a table lookup problem. So it's pretty clear that the stress of an English word depends on the weight of the syllables that make it up, as well as some aspects of its morphology. And we can divide the weight of syllables into three classes: heavy, light, and unknown, based on their orthography. And words, let's say, have from 2 to, let's say, about 7 syllables. And so at the longest, we've got 3 to the 7th possible weight patterns. And we just need to go through the lexicon and look for the words whose pronunciation we know, what the mapping from weight string to stress string is, or what the mappings are. Pick the mapping for each weight, if there's variation, which there is. Pick the mapping which is commonest, and we're done. We've solved the problem insofar as we can based on the information available. Now, as an engineering solution, as long as you don't worry too much about a little bit of extra storage for the table, which you can try to summarize various ways if you're worried about that, this is a fine solution. It actually works quite well, and it's the solution that we used internally in our system for a long time. I don't know what they do at Bell Labs now. From a linguist's point of view, it's quite awful, because it implies that any possible function from weight strings to stress strings is equally okay. And of course, linguists fervently believe that it isn't, that there are important regularities in the relationship between weight and weight patterns and stress patterns. For a psychologist, likewise, I would think this would be a rather unsatisfactory solution, because you would precisely be interested in questions like, if you give people new words with various kinds of syllable weights, where would they put the stress? You know, is this a good model of what they do? And then you would try to evaluate the linguist's claims about the alleged internal structure of what they do, as opposed to this kind of table lookup, approach. But there's no way. I mean, I'm abstracting away from some problems about morphological analysis and so on, but there's basically no way in which a more insightful solution from the linguist's point of view to the problem of why you get one particular mapping from weight strings to stress strings rather than another, there's no way in which a more insightful solution to that problem is going to change the mapping. So once you know the mapping from an engineering point of view in a letter-to-sound rule system, you're done. There's just no, at least unless you can make some kind of claim to the contrary, there's no reason to go any further. See, this relates in a way to the sort of physics question as well, because if physicists of earlier centuries had had the kind of computers and instruments that we now have, which is maybe a contradiction in terms, because how could we have gotten there without the physics? But anyway, it's not obvious that they would have chosen to beat their heads against the wall trying to figure out the rules that govern the way the planets whirl in their orbits, because after all, it's just a table. I mean, to any degree of approximation, you can look at it. It's an iterated map. You can set it up as a sort of phase space mapping from quantized positions to new
They already
positions.
had the tables. They had the
No.
They just didn't have any machine to put them in.
Yeah, they didn't. Well, the tables weren't good enough, sort of, and they didn't have good enough observations, and they didn't have clever ways of statistically combining different observations to make good ones and so on.
The issue is prediction, wasn't it? I mean, the tables, or I mean,
No, you could predict arbitrarily well from a table of that
Yeah,
kind.
but here you have the tables fine and you predict better.
Mark, there are compelling reasons in good engineering why it makes sense to try to model the underlying system and not just rely on the table, both from a perspective of minimal description and also generalization to new related phenomena. If you want to, can you borrow from Japanese to help you rapidly bootstrap on a new language that has related phenomena? So,
Yeah, I agree entirely, except that those arguments have to be made in each case rather than completely accepted on faith, I think. I'm exaggerating a bit.
but most of the language engineers that I know actually are interested in trying to model the underlying system. Perhaps the motivation is different. It is more one of generalization, efficiency, and problem solving, as opposed to necessarily trying to find universal principles. But there's still a strong incentive for both parties to try to come to a more compact, yet robust model of the underlying phenomena.
Sometimes engineers act too much like linguists, in my experience. In this respect, sometimes they would do better to try less hard to understand the phenomenon and harder to just find a way of modeling it externally. But I don't think we disagree at all, actually, basically. I agree with you. I did want to make one other point relative to psychology, which is that at least in the area of phonology, and especially, but also in some areas of syntax, I think that the argument that linguists sometimes make about why the principles are important, which is an argument from learnability, is actually faulty. Because since phonology is a finite collection of facts, so to speak, in most cases, at least as long as you know sort of which basic dimensions of generalization to use, the learning problem can most often be solved by table lookup. And furthermore, it's most easily solved that way, it would appear, since it doesn't require any fancy learning algorithms other than estimation for the bins of the tables that you're constructing, for the counts of the bins in the table that you're constructing. And so one of the issues for the psychologist is to try to explore the question of whether the ways in which learning takes place actually provide some evidence that what's going on is different from that. And I think this relates actually to a lot of your work, where precisely the question is, what are the characterizations of classes of stimuli that allow you to predict the way in which learning will occur given particular kind of exposure.
So David was talking about why the distinction between the engineering approach and the linguistics approach may not be completely valid, since a good linguistic description would help you build a better system. For example, using an example of letter to sound rules. If in fact someone gave me a good description of how to generate sound, well, say phone sequences for every word, I would prefer it more than a dictionary, simply because the next time I run my system, someone's going to use a word that I've never seen before. But I would imagine that a system would be useful in the other direction too, because what better way is there to test a linguistic theory on, say, letter to sound rules, than to go out and try it out on a large amount of data, not just a few examples, but millions of words or so on, as we use in speech recognition, and see in what number of the cases does your theory agree with the empirical data, and compare theories in this way. I think it goes both ways.
I think you're correct, but let me try to be a little more precise about what I'm saying, what I believe about this. A description that embodies no generalizations whatsoever is hopeless from an engineering point of view. In particular, if you start from nothing but the raw audio or audio-video, you have big problems. And so up to a certain point, the more appropriate sorts of classifications of the data that you make the easier the rest of the process will go. And if you get the right kinds of descriptions up to a certain point, then generalizations will happen more easily, learning and adaptation will happen more easily, prediction will work better. Certainly all of the patterns that I was showing you at each point where I said, here the engineer will be happy to stop, these were not raw data. They were certainly not raw sound files, but they weren't even raw text. Rather, they were classes of textual sequences arranged in paradigms. So I said, you know, the object pronouns following high-tone verbs. And the assertion was that whenever you have a high-tone verb, this is the pattern of the object pronouns. Whenever you have a mid-tone verb, this is the pattern of the object pronouns. That's already a considerable amount of descriptive generalization used to construct those rules. The point is that once you've gone that far in the direction of having the right dimensions along which to generalize, once you've gone far enough that you can, in fact, successfully predict the external distribution of the phenomena, then the next step, which the linguist wants very much to take, which is to ask and answer the question why. You know, why that distribution rather than some other, is not obviously relevant. It may or may not be. It may be that if you ask the why question, you'll learn about some new descriptive dimensions which, when added to your system, will make it work much better, but maybe you won't. You really don't know. And given that most engineering systems, especially in their early stages of construction, but even for relatively well-developed ones, work very badly at most things. If you want to make a good system with the broadest possible coverage, once you've got one subdomain nailed, the logical thing to do is to let it go and go on to something else and not worry your head over much about why it works the way it does, even though you can predict the way that it works. And I think, curiously, it turns out that the relevant level of description is not far from the sort of traditional norms of descriptive linguistics, which in fact all linguists still share, sort of as a way of expressing the data that they then go on to try to explain. Yes?
So I'm trying to figure out whether this difference in perspective or sort of whether the linguist is whether the engineer is getting annoyed with the linguist or vice versa, have to do with sort of the particular task that's being addressed. So in particular, you talked about kind of letter to sound rules. But so what I'm trying to understand is what the desiderata of the two groups are.
It could be morphological analysis, for example.
Well, in linguistics, what I sort of take to be what Chomsky put on the table as the desideratum for general linguistics was the learnability problem. Now, I sort of take your point.
In phonology, I think that's a fake.
Right, so then it sort of leaves the other desideratum, which I guess in the case of syntax and I guess in general is sort of less of a strong argument, has to do with the generality issue, that there are these sort of cross-linguistic generalizations and we see properties emerging over and over. It seems to me, well, that's always seems to me a weaker argument for trying to construct abstract descriptions that characterize commonalities, because they could just be accidents, right? I mean, there's always that possibility. I mean,
well, also more general and deeper descriptions are not always more useful. Sometimes they are, and sometimes they aren't.
Right. So imagine we're at a point where we have a perfect linguistics, right? Where we have a linguistics that's much more successful at characterizing patterns. Will there be a point? I don't think it's simply the case that if it's really, so is it the case in your impression that, my feeling is that we have a linguistics that could actually address these problems of sort of dealing with the learnability problem, and at least to a first stab, dealing with kind of cross-linguistic generalizations. You could still ask the question why and get deeper and deeper and deeper. But after a certain point, from the point of view of getting the data as a linguist, it's hard to see what the motivation for going further is, apart from some inadequacy in what the theory explains. And
So
so,
it depends on what the answers are. If the, the answers to some why questions are very uninteresting, they're just, because they're so complicated. But sometimes the answers are interesting.
but is there a point, I mean, suppose that the engineer is interested in the problem of building a system that will automatically acquire sort of low-density languages from speech or from text or what have you. They're interested in the same, say, the same learnability problem that the linguist is interested in. So presumably, to some degree, at least a linguistics that's better developed than today's linguistics that can address that problem in some real sense would be of interest to the engineer. So at what point does it happen that linguists start doing things that the engineer interested in that task would no longer be interested? So I'm just wondering to what degree this story you told us is a fact about the task that you're worrying about. If you sort of let the engineer consider a sort of more grand task that's perhaps not feasible now, wouldn't their concerns match to a good degree the same concerns of the linguist? Or not?
I don't know. I think it's hard to tell. It does seem like a plausible perspective that somehow having a system which works in terms of the same basic dimensions and the same basic modes of combination that the human system does would do a better job of learning in the way that the human system does. But, it's not, I don't know that that's necessarily true, and I think it remains to be seen.
Right, I would think that in terms of what limitations we have as humans might sort of factor into what the most feasible engineering solution is. So, I mean, just to pick one sort of dimension, limited memory or limited attention spans that we have and stuff like that, which might not be a problem for a computational system, then the most elegant solution that you could come up with that would solve the problem more efficiently might rely on something very different than what we're relying on as humans. Right?
Yeah, I mean, this kind of problem comes up all the time. I mean, I don't know, people who worry about secondary and tertiary structures of proteins. The question is, do you really have to do it all in terms of quantum mechanics to get it right, or are there some, which is the way nature does it, or are there some shortcuts that would allow you to capture what's really going on? And the people who try to do it in terms of fundamental modeling have never gotten very far because the problem is too difficult. So all of the practical solutions up to the present involve, various kinds of hacks in effect, which are, I mean, from the point of view of the physicists, they're hacks. They may involve extremely clever algorithms and data structures. And from everything I understand, that's likely to, I mean, I learned about this first. I was just reminded of this the other day because a book that I contributed a couple of papers to on string matching was just republished because there's a certain amount of interest in this area from bioinformatics. And I had learned a little bit about the bioinformatics applications in protein structure determination some 20 years ago, 25 years ago almost, and just, talked to some people about it a few weeks ago, and there basically hasn't been any forward motion, as far as I can tell, on the modeling protein folding from first principles front, but there's been a lot of progress on modeling the protein folding problem with clever hacks. And that could remain true for many decades to come. And it could turn out actually the problem can be completely solved by methods that have little or nothing to do with the actual underlying physics. I don't know, we're now speculating wildly about things that I know nothing about.